With these type of questions where they give us a paragraph explaining a lab situation and they give us two students' thought process and we're to select what was correct about each of the students' thought processes and what was incorrect, my suggestion is as you read through the paragraph, highlight it or annotate it so that you don't have to keep on going back and reading it over and over. So in this experiment, two carts shown in the diagram have a spring compressed between them. A string holds the carts together. A teacher asks the students to predict which cart will have greater kinetic energy and momentum after the string is cut and the carts are all away from each other. So now we start seeing what John thinks. John says that cart A will have the same amount of momentum as cart B because of the law of conservation of momentum. So that's John's first statement. And we know that in all collisions and explosions where there are no external forces acting on the system, conservation of momentum does say that if the momentum initially was 0, then the momentum of cart B to the right would have to equal the momentum of cart A to the left, and so that is a correct statement. He also says that they will have the same amount of kinetic energy because of the law of conservation of energy. Now this statement is incorrect because while they will have the same momentum, the different mass results in different speeds for the two carts. And since kinetic energy is 1/2 mv squared, the fact that they have different masses and speeds will result in different kinetic energies. So I'm going to mark that one as wrong. So let's fill this in. What aspects of John's reasoning were correct? John was correct in saying that their momenta were equal in magnitude. Because they both started with 0 kilogram meters per second of momentum. So whatever momentum B gained to the right, A must have gained to the left, so that the total momentum is still 0. So now we have to write down how he's wrong about his kinetic energy claim. So we would say that kinetic energy the kinetic energy of each cart is not the same. I think we can see that the speed of cart B will be twice the speed of cart A, since it has half the mass. So since kinetic energy is 1/2 mv squared, doubling the speed while having the mass results in twice as much Ke for cart B. Right, so conservation of momentum tells me that B is going to go twice as fast as A. And then the kinetic energy formula, which squares the V, makes the kinetic energy of B greater than the kinetic energy of A. Okay, let's look at what Sarah thinks now. Sarah says cart A will have less momentum than cart B, which we know to be untrue. But its kinetic energy will also be less than cart B because it's more massive and therefore will move away more slowly. This is true, and so we can restate the law of conservation of momentum. Since conservation of momentum must hold in this situation, B, which is half of the mass of A, must attain twice the speed. Since Ke equals 1/2 mv squared, the cart with twice the speed and half the mass of the other will have twice the kinetic energy. And like we just said, this idea that one cart will have less momentum than the other is not true. It's not true because the initial momentum of the two carts is 0, and so the final momentum of the entire system, both carts combined, must be 0, meaning the momentum of cart A to the right must equal the momentum of cart B to the left. So, alright, since the law of conservation of momentum must hold, and since both carts start from rest, the momentum of B to the right must equal I should really be saying the magnitude of the momentum of A to the left.